Hi guys, welcome back. We're going to be doing a whole mini series on recurrence relations. This is under the umbrella of sequence and series. So if you're interested in sequence and series, I've already put out there a series about geometric series, and next week we'll be filming arithmetic sequence. So let's get started. If you don't know what a recurrence relationship is, a recurrence relationship basically tells you if you've got one term, how do you get the next one? Think about it like a process that once you feed in the previous answer, out will pop the next one. So for example, here, we've been told find U2 and U3 and U4. Now, just to deal with the notation, in the sequence, U1 would be the first term, U2 would be the second term, U3 would be the third term, and U4 would be the fourth term. So this little number here, it's called a subscript, this little small number here denotes where in the sequence you are. So if you were the seventh number in the sequence, you would be U7. Now we're told what the first one is. So we're told what the first one is so we can get started. So the first one's going to be 2. Now we need to work out what U2 is. So what we do is we go to the formula that we've been given. In this case, we've been asked to find U2. Okay, so we want n to be 2. So if n is 2, what is n minus 1? Well, 2 minus 1 is 1. So we would say 3 times u1 minus 1. And this is where we need to feed in the previous answer to get the next answer. So we know here that u2 would be 3 times u1. Well, u1 was 2, so 3 times 2 minus 1. So U2 needs to be 6 minus 1, which would be 5. So let's repeat this process with U3. So to get U3, we would need to have n now would need to be 3. So it would be 3 times n minus 1. So think about this. If this is 3 now, 3 minus 1 would be 2. So it would need to be 3 times U2, which we did in the previous step, minus 1. So U3 is 3 times 5 minus 1. U3 would be 3 times 5 is 15, minus 1, 14. So we can't ever directly jump to U4 with this recurrence relationship without knowing U3. We always need to feed the previous answer in. So now we would need U4. U4 would be 4 minus 1 would be 3, would be 3U3 minus 1. So U4 would be 3 times 14 minus 1. U4, 3 times 10 is 30, 3 times 4 is 12. So it'd be 42 minus 1. U4 would be 41. And you could continue indefinitely like that. So a recurrence relationship is where you use your previous term to generate your next term, or maybe your previous 2 terms to generate your next term. State the recurrence relations for the following sequence. So in this recurrence relationship, I want to start by writing down my first term. U1 is 4. 4, 6, 8. So each time I need to add 2 to the previous term. You could basically write this down 2 different ways. You could write UN being the next term is equal to UN minus 1 being the previous term because it's 1 behind. So if this is n minus 1 is the one before, plus 2. Or you could similarly write it as UN plus 1 is in the one in front would be UN plus 2. It doesn't really matter. Both of these would be perfectly correct. You might want to also state that n is an element of the natural numbers, and n in this case would have to be bigger than or equal to 2 because the recurrence relationship starts on the second one. You've been given U1 is 4 and it starts on U2. Now this recurrence relationship is going to use the previous 2 terms because we've got UN plus 1. So if we think about n plus 1 being here, and the formula uses n and n minus 1. So in this case, To get the next term, you need to use the previous two terms. So I'll show you how that works. We've got U1 and U2. So let's get U3. So we start by working with the formula. What I always like to do is write down the formula first. So in this case, if I want U3, I would write down U3. Then I know that n plus 1 is equal to 3. So that must mean that n would be equal to 3 minus 1, n must be equals to 2. So that would be 2 times, in this case, un, I know n is 2, u2 minus 1 plus 4, bracket. Now, n minus 1, if n is 2, n minus 1 would be 2 minus 1, which would be 1. So it'd be 4 times u1 plus 2. So now I just need to substitute in. So 2 times u2 was 5, 5 minus 1, plus 4 times u1 was 2, plus 2. 5 minus 1 is 4, 2 plus 2 is 4 also. So it's 2 times 4, which is 8, plus 4 times 4, which is 16. And 8 plus 16 is 24. So in this recurrence relationship, we not only used the last one, un, but the previous one, n minus 1, to get the one ahead. Now, sometimes you're asked to work out these terms, but in terms of a letter. So here, in terms of A. It's going to work exactly the same. So it says, find in terms of A. That means there are going to be A's in your answers, not just a numerical value. Might be something like 3a plus 5. U2 and U3, given that U1 is equal to A, and we've been given the recurrence relationship here. So let's start with U2. U2 is equal to 5 times, now if n plus 1 is 2, n has to be 2 minus 1, n is 1. U1 minus 1 plus 3a. So the first line you can see I'm always writing down my formula, which terms I'm going to need. And on the second line I'm substituting in. So U2 is 5 times, now I'm going to substitute U1 for A, minus 1 plus 3a. You always want to simplify your expression, so I'm going to multiply out these brackets. So it'll be 5a minus 5 plus 3a. Then I'm going to add together the like terms. So 5a plus 3a is 8a minus 5. And I'm going to go to the next step using the same process. So now, put this one down. I want to get U3. So n plus 1 is 3. So n is 3 minus 1, n is 2. So I say 5 times U2 minus 1 plus 3a. Now I'm going to substitute. U3 is equal to 5 times U2 was 8a minus 5. And I've got another minus 1 plus 3a. I'm going to start by working out this bracket. So 8a minus 6 plus 3a. Multiplying out the bracket, 40a minus 30 plus 3a. And now adding like terms. So 40a plus 3a would be 43a minus 30. And that's it. It's exactly the same process. The only difference is that your answers contain a's. The last one, find in terms of a, U2 given that U1 is 2a minus 1 and un plus 1 is un squared plus 3. So I hope you're starting to think about this like this. The next one is equal to the previous one squared plus 3. So let's get U2. Let's substitute in U1 and multiply out the brackets. And add together our like terms to simplify fully. And that one's done. That's the end of Key Skill 1. So what I really want you to take away from this lesson is a recurrence relationship is a system to generate new terms using the previous terms. we feed in the previous term or sometimes the previous 2 or 3 terms into a formula, and that generates the next term. It's like a wheel going round. So each time we get a new answer, we feed it in and we get the next answer. Then we get a new answer, feed it in and get the next answer. So I hope you enjoyed that, guys. We're going to be doing more tricky problems with recurrence relationships in Key Skill 2. I look forward to seeing you in the next video. Bye for now.